Okay. So I'm gonna do the homework first, but some people missed the class and didn't do the homework, but you still need to watch the lesson and try the homework, but I'll do the answers anyway. So yesterday, just to say for the people here, I mean we did something new yesterday. We were looking at Q, which is charge, I, which is current, V, which is voltage. Did we do that? No, we didn't do that yet, sorry. And actually, yeah, just those two. And yeah, and charge is measured in coulombs and current is measured in amps. The same thing. Amps. So, for example, with an electron, the charge is negative, and with a proton, the charge is positive, and with a neutron, the charge is 0. But I need people to look at that lesson again yesterday. Anyways, I'll go through the questions. The only formula that you had from yesterday was this one.
Yeah.
Or sometimes just Q is IT. Okay, so let's have a look at the questions. So in the first question I said a 2 amp light bulb is left on for 1 hour. I should say how much charge is passed through the light bulb. So you have Q equals IT, so that's 7,200 coulombs. An electric heater requires a current of 13 amps, and the charge is minus, because of the electrons, 46.8 kilo. What's the time? So if I use Q equals IT, I don't really need the minus here. The T is Q over I, which would be, let me see, 46800 over 13. What's that? Can you type it in, please, KJ? So this will be in seconds.
$3,600.
1 hour.
Yeah, exactly.
3,600 seconds.
Just plus it.
Huh?
Plus, make it plus.
Yeah. Okay. Number 3. In number 3, what you had is you had some lightning. Some lightning hits the ground. And I tell you here that the time is quite small, of course. Here, look, I'll even draw clouds for you. So the time is quite small. It's only 50 milliseconds. And the charge is quite large. 1.5 kilo coulombs. There's a lot of charge. So the question is, what's the I? Yeah? No. The question is what's the I? So Q equals IT, I equals Q over T, which will be 1500 over 0.050. What's that, please? Let me see. Can you type it in? I know that counts as with that. That goes in 3,000?
30,000.
30,000. Okay. 30,000, which would be 13 kilo amps. 30,000. So a lot of current. Okay. 2 more questions left. Number 4. Can I scroll down? Yep. Number 4 is a little bit difficult. In number 4, what's happening is you have a copper wire. And inside the copper wire, there are copper atoms. And on the copper atoms, there are, of course, electrons. I'm not drawing this at all accurate. And what's going to happen is, if there is a current, it's because the electrons which are free are moving. These are electrons in blue. So in the question I tell you that there are 8.5 times 10 to the 28 atoms of copper per meter cubed. And I say each atom has 1 free electron. So that means there's 8.5 times 10 to the 28 free electrons per meter cubed. I also tell you in the question that this is 1 millimeter. And I don't tell you the length here. We'll just call it L. So the volume will be pi r squared L, which would be pi 0.0, that's 1 centimeter, that's 1 millimeter. KJ, do you mind typing this number in here on the calculator and tell me what you get?
Why do I put it?
Huh? Radius.
It's 1 millimeter.
Wow.
Diameter.
Oh, yeah.
What is it?
7.85
Yep.
times 10 raised to the power minus 7.
Minus 7
L.
L. That's the volume. So, the number of free electrons. So, for example, just think about this for a moment. Let's imagine the volume was equal to 1 meter cubed. Then how many free electrons would you have? You would have this many. True?
Yeah.
Let's imagine the volume was 2 meters cubed. How many electrons would you have? Multiply this by 2. So therefore, if I want to know how many electrons I have, I just take this number and then multiply it by this number. So again, KJ, can you give me that, please?
N.
Number of electrons.
6.67 times 10 raised to the power 22.
Okay. Now, We are told in the question that the current is equal to 3. So that means Q over T is equal to 3. But we also know the Q is equal to N multiplied by E. Now, what's happening here is, well, sorry, no, let's go back a step, sorry, that's too much too fast. So we have Q over T equals 3, because I tell you it's 3 amps, okay? Now, that means in 1 second, how much charge do we have in 1 second? If T is 1, how much charge do we have? 3 coulombs. Okay? So what I'm going to do is, I'm going to look at this for 1 second. So what's going to happen here is an electron is going to come in here, and then travel all the way through the cable, and then come out here in 1 second. Just to make things easy. Okay, so we're looking at this for 1 second. So that means the Q should equal 3. How many electrons move through 1 second? Well, I told you how much charge 1 electron has. Do you have that from yesterday's class, KJ? No, seriously, because I don't remember the number. What was it, like 1.6 or something? 1 electron has charge of what?
Minus 1.6 multiplied by 10 minus 19.
Coulombs.
Yeah.
Now that's 1 electron. How much charge do I have? 3. Okay. Total. So if I want to know how many electrons I have, I should take this number and divide it by this. Let's not worry about the minus just yet. I'll fix that later. So the number of electrons should be 3 divided by 1.6 times 10 to the minus 19. How much is that, please? Can you calculate?
Is it 19 or minus 19?
Minus 19. So it'll be a large number.
1.875
Yep.
times 10 raised to the power
10 power
19.
19. Okay. That's how many electrons I get per second.
Why did you throw away the minus?
Huh? I'll fix it later. Do you remember what this number means? It's how many electrons I have per, do anyone remember? Per meter cubed, this number.
So now we'll have to get L, right?
Yeah, almost. I want to calculate the velocity. So, do you remember that we have our triangle distance, speed, time? And that distance is speed multiplied by time. What's the time in this question? 1 second. So here you have distance equals speed. The distance is the L, and the speed is what I want. So you have, it's getting messy now, 6.67 times 10 to the 22 V. No.
No.
Let me think. Now, just give me a few seconds. No, just give me a few seconds, and then if I don't know, you can tell me. Yes. We'll do what you suggested, Karar. We'll get the L. Yes. Yes. So this is how many electrons I need per second, and this is how many I have per meter cubed. But these electrons are moving, so can somebody please do this number divided by this number? Actually, you know what? This question is getting too difficult. I am going to do this one again, maybe on Friday's class. But I can already feel like I still have it only 50% finished, and I think it's getting too difficult. So I will do this, but I'll do it later after people have watched the video. Okay? So anyways, to be continued. What? To be continued. Okay, the last question here is 4, sorry. And basically it's actually not too difficult. I say that I have one wire with current I1, another wire with current I2. How much current do I have here? Well, it turns out it will be I1 plus I2, but why? Why do they add together? Well, if you think about current is Q1T, and here it's Q2T. So if I'm looking per T, here I have Q1, and here I have Q2, and they come together. So I must have Q1 plus Q2. In other words, the point I'm trying to make is a current adds together. That's all. That's all. Okay, do you have that?
Yes.
Yes? Do I want to... I shall do this one again on Friday, maybe, but I'll make it a little easier. What I'll do is, in the question, I'll give you the length as well. This will make it easier.
Exam question?
Today?
No, not today.
Final exam?
Yeah.
No. The exam questions are just 1, 2, 3. Exam questions. Yeah. Alright, I'll fix it.
No exam.